right, good morning, everybody. So in the last class, we were talking about file I/O. So remember in C, the way the file I/O works, you open up a file for reading or writing or appending. We'll talk about that in just a second. You get back a pointer to a file object. You do something with the file object. So you either write to the file, you read from the file, you do something with the file. When you're done with it, you close the file. Okay, so when you open the file, you use the function fopen, right here. Right, so to open a file, you pass in a path name. Right, so typically, for our purposes, this is going to be the name of a file on your disk somewhere. So here I'm writing into the file afile.txt. Text, there we go, right? And when you open the file, you have to say what you want to do with the file. So there's this mode here that you pass in. It's a string. And so I noticed the notebook's kind of screwed up, so I fixed it just a brief time ago. There's that bar is missing in the raw markdown. So if you put it back in, the table renders properly. Otherwise, it just looks like gibberish. So the mode is one of these 6 values here. Right? So you read, write, append. R+, W+, and A+ are the extended read, write, and append modes. So the plus modes let you read and write or append and read from a file. Oh, sorry. Okay. So we're mostly concerned with read, write, and append. So R opens a file for reading. If the file exists, then it starts to, when you read from the file, it starts to read from the beginning of the file. So it does the sensible thing. If the file does not exist and you try to open up for reading, you end up with a failure of some kind. And so the value returned by fopen will be null. Right. If you want to write to a file, you pass in the W as a string. Right. Now, if you write to an existing file, notice what it does. It destroys the contents of the existing file and then starts to write at the beginning of the now destroyed file. Right. So write means overwrite the existing file, getting rid of all the contents before you start writing. If you try to write to a file that doesn't exist, the function makes a new file for you. And similarly with append. So the difference between append and writing is that when you append to a file, all the write operations occur at the end of the file. Right? So you're adding to the end of the file continuously. For the extended modes, they basically open up the file for both reading and writing. So R+ and W+, they more or less do the same thing, except when the file, except on creation of the file. Right? So if you open up a file for read extend mode, it starts reading from the beginning of the file. If you start to write to that file, I believe it writes to the current file position, which I'll explain in a few minutes. If you open a file in write append mode, it destroys the contents of the file, so it overwrites the file. Now, append extended is an interesting one. So append extended lets you read and write to the file at the same time, but all writes are treated as appends. So they all write at the end of the file. Yeah, right. All right, so we're mostly interested in R, W, and A, and mostly we're interested in R and W, right? So basic reading and writing from a file. All right, once you're done with the file, so after you performed your read and write operations, which I haven't showed you how to do yet, you then close the file. Right? So in Linux, the way this works is that the operating system has what's called a file handle for every opened file. And Linux uses files for everything, right? Your network connection is probably a file of some, well, it might be a file of some kind. Your hard disk is treated as a file of some kind. If you had an optical drive, it would be treated as a file of some kind. Your files are treated as files of some kind. Even your terminal and your keyboard are treated as files of some kind. And so there's a limited number of file handles that the operating system has available to it. If you continuously open up files without closing them, you eventually run out of file handles. And because Linux uses files for everything, you basically can't use your operating system anymore. Right? And so when you're done with the file, make sure to close it. It does return a value, but no one looks at the return value. Right? So right down at the bottom there, it tells you fclose can fail, which is weird, right? So how can closing a file fail? Right? Something weird must have happened, right? If something sufficiently strange happened that fclose fails, you probably can't do anything about it. So almost no one looks at the return value from fclose. Once you close the file, you can't use that file pointer anymore you can't use the file pointer as it is for any other operations, right? If you try to use it for any other operations, anything's allowed to happen. All right, so when you're working with files in Unix-like systems, you have to remember that files are basically streams of data, right? And so you can think of it as basically being a giant array. So an open file has a file position, and that position points at the next character that will be read or written. And so in Linux, the file position is equal to the number of bytes, I think. Yes, number of bytes from the beginning of the file. Right, so the first character in the file has position 0, the next character in the file has position 1, and so on and so on and so on. Right, in Linux, there's no difference between a text file and a binary file. Right, so file that's data that's encoded somehow that's not text. Linux doesn't care. Right. It's all just bytes still as far as Unix and Linux is concerned. Okay, so when you open up a file for reading or writing, the file position is always set to 0. So it's always the beginning of the file where reading or writing occurs from. Right. Opening up in A or A+ mode causes the file position to be treated specially. Right. And so in append mode, all write operations always append at the end. Right? So it ignores the current file position. Everything happens at the end of the file. Right? When you read, that's when the file position is actually used. Right? So reading operations occur at the current file position. That's fine. And functions. All right. So a little bit later in this notebook, we're going to look at an example where you specifically manipulate the file position to perform operations on a file. Unformatted I/O. Unformatted I/O reads. So this is all unformatted input and output that we're about to talk. That we're going to talk about. So unformatted I/O reads and writes individual characters or strings into a stream. Right? So this is not what you want to use if you want to write. Is that true? Hang on a second. Yes, if you want to write like numbers or something to a file, you want to do formatted I/O. Right? The values have a specific meaning. Right? So the value you want to write the value of the int into the file. You don't want to write a string into the file. That's formatted I/O. Okay, so you can read a file one character at a time if you so choose. You can just use, so the function is called fgetC. So fgetC, you pass it in a pointer to a file, and that will read a character from the file, right? One character. For historical reasons, it does not return a char, it returns an int. Right, so in the old days of C, when there was no, when they were using ints for more or less everything, they made the return type for fgetC int instead of char. Right, so even though the return type is int, you can treat it as a char. So when you read a character from the file, what happens is you read from the current file position, and then the current file position moves to the next character. Right, so it's like using an iterator in Java. The character is technically returned as an unsigned char converted to an int. So that's what it technically does. We don't care. It's basically a char. Okay. If this fails for some reason, so if you're at the end of the file and there's nothing left to read, or if that stream is invalid, this returns the value EOF. Right? You don't care what the actual value EOF is. You just use the constant EOF. Right? And I don't remember what that value is actually. Anyway. Okay, so here's a little example of reading a file one character at a time. So that's the name of the file that I'm about to read. What am I using the status for? Right. I guess I'm going to assume that this program is going to fail. So I'm going to be pessimistic here. I'm going to open up the file to read. Right. Remember, when you open up a file, this can fail, right? So if there's something wrong with that file name, if I don't have read permissions on it, something else, right? Something's wrong with your disk, that thing can return null. So unlike malloc, you should always test whether or not the returned pointer is null, right? If it's null, you can do whatever you need to do for your particular, in your particular case. Right here, I'm simply going to exit the program. Okay. Otherwise, I'm going to, if I successfully open the file, I'm going to read the character. I'm going to read the file one character at a time. The canonical way to do this in C is to write the loop that looks like this, but this is a little bit confusing for most newer C programmers. So you declare your character variable C, right? So this is where I'm going to store the read-in character, and then you're going to call fgetC, and you're going to store the value in C and wrap the whole thing up in parentheses. Right? Okay, so what does this do? So it calls fgetC. Right? fgetC does its thing, reads a character, stores it in C. Right? And now you have to remember that assignments in C have a value. Right? So everything that's highlighted there actually produces a value. It produces the value of C. Right? This is also a similar trick that's used when you use an assignment as a condition. Right? Because the assignment has a value, you can use it as a condition for an if statement, or in this case a while, or not in this case, or a while loop, right? Or some kind of loop, right? So the value of all this is C. So whatever character was read in from the file, right? So if that character is not EOF, then we know that we've successfully read in the character, right? So now you can do something with the character. I treat new lines specially. So if you read the last character, so in Linux, at the end of every line is supposed to be a new line character, right? That lets the next line of text appear on the next line, right? So every time we see a new line character, I actually print out new line char instead of printing the new line character directly. Right? Put char, we haven't seen this yet, is like puts. So puts writes a string to standard output. Put char writes a single character to standard output. Okay, so we see anything other than the new line, I'm just going to print the character to standard output. So what is this doing? This is basically echo, right? This is basically implementing echo, except that we're treating new lines in a special way, right? This is going to read a file and output the contents of, not echo, I'm sorry. This is basically implementing cat, right? Reads a file and outputs the contents of the file to standard output. All right, so once we get through the loop, at the end of the loop, if we encountered any kind of error, so ferror f. So the ferror function tests if an error has occurred while using that pointer f. So this is one of the functions that you find in standard I/O. Right. So that the return value of ferror f is true if an error has occurred while doing some file operation with f. Right. So if an error has occurred, I'm going to print there is some sign of I/O error here. Right. If you reach the end of a file, that's not considered an I/O error, right? So there is a difference between reading to the end of the file, you're now done reading the file, right? And an error occurring while you're reading the file. And so FEOF tests whether or not f is pointing to the end of, the current file position of f is at the end of the file, right? So if it is, we've successfully read the contents of the file. So I can set the status to exit success, which is 0. Right? Close the file when we're done with it. Right? Return the status. Okay, so what does this do? Not surprisingly, prints the contents of the file. So the contents of that file is just line 1, new line 2, new line 3, new line. Right? And so that successfully echoes the contents of that file. What else is in there? I guess we can change this. Read file 1.c. So let's read the program itself and see what happens. And so there's the program itself, right? Except that the new lines have been replaced with new line char, right? And there's the contents of the file. So if we get rid of that, I suppose, and run it again. Oops. Cannot print, oh, that's an empty formatting string. Not allowed to do that, sorry. Let me comment that out. There we go. That's basically the cat program. Well, that's the simple form of the cat program. Right. So if you wanted to implement cat without the command line options, this is one way to do it. Right? Read the character, open the file, read it one character at a time, simply print the character to standard output. All right, so any multi-line file in Linux or Unix, well, sorry, in Unix, the end of every line is supposed to end with a new line character. Right? In Windows, it's something else, right? So when you are transferring files between Windows and Unix, it's a little annoying. Windows uses a different end of line terminator. Oh, it even tells you that right there. Mac is also a new line character, is also \n. That explains what ferror is. That explains what feof does. This explains how to clear errors indicated that occur. Right? So there's a clear error function that can clear the error status if you want to use it. Okay, so there's reading a character. There's reading one character at a time. You can also read entire lines at a time. You have to be careful with entire lines. Reading a character, reading a file one character at a time is always safe, right? You know exactly how much data is being read in. It's one character, right? fgets reads in a line of text. Now the problem with this is that you don't know how long a line is in a file, right? In Unix, there's no, I don't believe there's any upper limit on the length of a line. So if you blindly try to use fgets, right, to read into a string, you can easily run past the end of the string, right, if you read in a very long line of text. To make the function a little safer, fgets requires you to pass in how many characters do you want it to read, right? So this isn't guaranteed to read an entire line. It'll read in up to count -1 characters from that file there, right? And it stores them in this string here, right? So what does that mean? It means this string here has to be has to have capacity at least equal to count, right? Because you need to store the new line terminator if it happens to be, the end of string, the null terminator for the string, right? When you write it into str, right? That's why it only reads in count -1 characters and not count, right? Because it has to write the null terminator into str, right? So the problem with this is that if you don't know the length of lines in your file, you always have to check whether or not the last character in the string is the new line character or not, right? If it isn't the new line character, then you know there's still more stuff left to be read in from that line. So when it reads in the line, it advances the file position to the next character after the last character it reads in. And it returns, the return value here is simply equal to str, right? So that you can pass the result of this function to another string handling function if you so desire. What happens with read failures? Oh, yes, fun. So if something happens, so if something goes wrong when it's trying to do the read operation, does it actually, yes. The pointer that's returned here is equal to null, right? So one way that you can test for whether or not this function succeeds is to look at the return value, right? It also sets, you can also use ferror to look at any errors that are caused by fgets. All right, so let's read in that other, okay. So let's read in the file once again, this time one line at a time, right? So all of the starting operations are the same, right? You open up the file, right? You test whether or not the file was opened successfully, right? And now you're going to read things one line at a time. So the problem with this function is that you have to define a string where you're going to store the results. So here I'm going to make a local string or a local array of length 100, right? So I can store strings of up to 99, of length 99 in here. This is safe for this file, right? So we saw the contents of this file. I know it's just line 1, line 2, line 3. That's much less than 100 characters long. So I can easily store each line in this array. So this is safe, right? So here, unlike the fgetC example, fgets, we're going to look at its return value and test whether the return value is not null, right? Remember, if it's null, something wrong has happened, right? So if it's not null, everything's fine. We've read in a line of text, right? Now, notice the big comment that's sitting here, right? So when you read in the line, for fgets, the new line character is included at the end of the line. Most of the time, you don't want it, right? So most of the time when you read in a string, you want the string and not, or when you read in the line, you want the string corresponding to the line, but you don't care about the new line character at the end, right? So if that's the case, don't forget you have to strip that new line character off the end of the string, right? Basically what that means is you move the null terminator one position forward to overwrite the new line character. Right? Now in our example here, I'm going to take advantage of the fact that the new line character is there, so that when I print the string, it actually goes to the next line. Right? I don't have to put in the new line character here myself. Right? Okay, so what does that do? So not surprisingly, this is going to do exactly what you think it does. Boop. Right? Prints out line 1, line 2, line 3, the contents of the file. Right? Again, if you change the file name to something else, right? So read file 2, not C, it's just going to read in itself and print the contents of the file. Do I show you how to deal with that? I'm just going to quickly scroll ahead to see if I show you how to deal with. I don't. Okay. All right. So suppose you would like to read in lines of text from a file, and you don't know the maximum length of any line. Right? So when you're in that situation, you make your little array here to hold your string. You actually don't know how big to make that string. Right? Pick some number, hope it's big enough. Right? That will work until somebody gives you a file where it's not big enough, right? Then when you get to that situation, you read a line of text, or you read what you think is a line of text, and in fact you haven't read in the whole line, right? And so on the next call to fget, it reads in the rest of the line, or part of the rest of the line, right? But when you print it out or you do something with the line, it's on the next line. And so what you have to do here, inside your loop, right? You have to examine the last character of the string to see right. So if it's important that you're actually reading incomplete lines of text, right? You want to treat that entire line as a single string. You have to look at the last character in buff. Right, so you look at the character at index 98, right? The one at 99 is the null terminator, right? So the one at 98, you're going to look at it and test if it's the new line character. If it's not, you know that there's more stuff left to read in, right, on that line. So typically, if that's the situation you're in, you typically don't want a locally allocated array like this, right? You want a dynamically allocated array. Right, so dynamically allocate the array, right? Look to see if it's the new line character. If it isn't, reallocate the buffer. Right, you're going to reallocate the buffer, expanding it by some amount, right? And then let the next operation read into the rest of the buffer, right? Until you see the end of line character. Okay, so we can read and write a line from a file. You can also write single characters and write entire lines to a file. So fget c, read a character. Fput c, write a character. Right? What character you're writing the character ch. Right? Again, for historical reasons, the type of ch is int, even though it really is char. Right? That's a pointer to the stream that you've opened for writing or appending to. Right, where the output will go to. When you write a character into the stream, it writes the character and then advances the stream position one position. It returns the written character, so it returns ch if it succeeds, and it returns EOF on failure. Okay, so here we have the text file alphabet. So I think this is just the letters of the alphabet. So we're going to open up a file to write. Oh, I see what's happening here. We're going to write the alphabet into this file here. So I'm going to open up a new file. This time I'm going to open it up in write mode. Remember what that does? That creates a file if it exists. If this file is already in my file system, it's going to delete the contents of the file and start writing at the beginning of the file. Right. Again, don't forget the test to make sure that the opening actually worked. Right? And now I'm going to write a little loop, right, that loops over the characters lowercase a through lowercase z. Right? I'm simply going to write the character c to the file f each time. Right? Every time you perform a write operation, you should test whether or not the write operation succeeded. Right? So here I'm using ferr. You can also look at the return value of fputc. Right? I guess this is not necessary. Is that true? Ferr. If not ferr, make sure the new end line is the new line character. Sure, we can do that. And then close the file. Right. Okay. So yes, I guess this is important. So in Linux or in Unix, sorry, and this includes your Macs. In a file, the last character of every line in a file is supposed to be the new line character. So this loop here does not ever write the new line character to the end of the file. Right? And so you have to make sure that you actually put that new line character in, or you should. Right? The problem is if you don't, many programs or many commands will handle the file just fine if the new line character isn't at the end. Some programs rely on the fact that the new line character is there. Right? So for example, word count. So the WC program actually counts the number of new line characters in a file. So if you don't write that new line into this particular file, word count will think there's 0 lines in the file. So you should make sure that all of your lines terminate with the new line character. So this is what I'm doing here. Right? Close the file when we're done. Oops, sorry. Close the file when you're done. Right? And this program just ends immediately thereafter. So run that program there. We get no output because we didn't write anything to standard output. But if you actually go and look in that directory, which I guess we can do, IO, there is the alphabet. So, whoops, right there. Right? If you count the number of lines in alphabet, it's 1. Right? Now I'm going to do what you shouldn't do. I'm going to comment out that line and see what word count does when I run it on the new file. Oh, now I think there's 0 lines in the file, right? So there's an example of a program or a command that actually does rely on the new line character being at the end of every line, right? You can other programs don't care, right? So if I cat alphabet, it will actually print out the entire file. Right? Notice it doesn't print out the new line character, right? So my prompt. Sorry, let's try that again. No, it just. Okay, let's try that again. Cat alphabet. There, right? So notice that my prompt does not show up on the next line, right, where you would expect it to, right? It doesn't show up on the next line because there's no new line character after the Z here. Okay, so fputc, fgetc, pretty straightforward to use, right? Read and write a single character at a time. Fgets, read an entire line at a time. Fputs, write a string. Write an entire string in one shot. Right? So fputs writes the contents of that string to that file, returning the number of characters written, I believe. Is that right? No, it returns the number. It returns a non-negative value on success, so it doesn't tell you what it returns, right? And EOF on failure, right? So here, this is the cat example. Okay, so this is basically again implementing cat n. So the following program is going to read its own source code file one line at a time. It prepends a line number at the beginning of each line and writes the prepended file to a new file. So this is like cat with the n option. So cat, remember what cat does. I need a file. Cat n. Right, so remember cat concatenates the contents of a file, sending the results to standard output. It has a bunch of handy options, especially if you're working with source code. -n prints out the line number, which is often useful when you're looking at source code. So I'm going to implement basically cat program where we print out the line number each time and then send the results to standard output, to a file. Okay, so how does this work? Well, it's the same thing every time, right? Open up a file. Oh, this time we have to open up two, right? So I have to open up one to read the file. I have to open up a second one to write the output to. So there's why I open up the file, right? That's so we're going to open up cat nc. We're going to open up another file. So this is cat n with line numbers.txt, right? So that's the file I'm going to write to. So here we open up that one with write mode. We're going to open up the previous one with read mode. Right? We're going to write the line number in front of every line. So I need the current line number. There it is. You might use an unsigned type here, but that's fine. Okay, we now need the input and output. We now need the input and output line buffers. So I'm going to read in the file one line at a time. So that's where I'm going to read characters into. Right? Now I need to write out stuff, and I only know how to write strings right now. Right? So I haven't shown you how to do formatted file output yet. But previously I did show you how to write into a string. And so we're going to write the line number followed by the line into a string. And so that's what string out is. Right, now when we write the line number in, I need some characters for the line number. So here I'm assuming that the line number is at most 4 extra characters compared to the input string. Right, again, this is sketchy, right? You have to be very careful about doing this in production code. Right? In these little examples, this works fine because I know that the file I'm reading and writing to, the lines are never more than 100 characters long. Right? In real life, you never really know how long your lines might be. You have to be really careful about doing stuff like this. Okay, so how do you read the file? Well, I'm going to read it one line at a time. So I'm just going to use fgets. Right? When I read in the line, I now want to print that line to a string where the line number is at the front of the string. Right? So I'm going to use sprintf. Remember, formatted printing to a string. Right? We're going to print into string out. Right? And what would I like to write? Well, I like to write the contents of the original string. So there's %s. Right? And there's the contents of the string that I read in from the file. And I would also like to write out the line number. And I'd like to write it out in a way that's similar to, but not exactly the same as cat. Right? So notice that cat writes the line number out, and it's right aligned. Right? And it's got some spaces in the front here. So you can do that with sprintf. Right? %03d means treat the argument as though it were an integer. So there's the d, right? And it applies to line number. Right? The 3 means use at least 3 characters to print the string, right? Or the line number, sorry, right? And if you don't need 3 characters to print the line number, insert zeros at the front. Is this zeros? This is going to be zeros, right? Insert zeros at the front. Write the string using fputs. Right? Close the files when you're done, and let's see what we get. All right, so run the program, compiles cleanly, right? No output. Go and look at the file. Cat n with line numbers, and there you go. Right. So the printing of the line number is not exactly the same as what cat -n does, right? But you can make it look like what cat does if you wanted to, right? Go look up the formatting options for printf, right? And it'll tell you how to write this line number. Oh, sorry, how to. Oh, come on. And it will tell you how to print out this line number so that it occupies some number of spaces and that there are no zeros here, right? And everything's right aligned, right? There is a way to do it. Okay, so there's reading and writing single characters, reading and writing lines of stuff at a time. Okay, so what about reading and writing structured data, right? So what if I want to print a number to a file or something else, right? So print a floating point number to a file, print a string to a file, print a character to a file, or something like that. right? So it turns out you already know how to do it, right? So you know how to use printf and sprintf. Fprintf works the exact same way, except fprintf prints to a file, right? So it's basically printf, except you pass in one extra argument, which is a pointer, which is a file pointer, right? And now you can write formatted data to a file, right? If you want to read formatted data from a file, right? So remember we saw scanf earlier when we talked about strings, right? So can you parse a string for content for information from the string? You can do the exact same thing with a file. You just use fscanf instead of scanf, right? You pass in a pointer to a file instead of passing in a pointer to a string, and everything's exactly the same as before. Right? So it turns out we already know how to do that. All right. So back at the beginning of the lecture, we talked very briefly about the file position, right? So remember, you can think of a file as just being a stream of data, right? Each location in the stream has what you can think of as being an index, right? There are functions that let you manipulate the file position directly. There are several of them, and there are several extensions as well that the GNU compiler gives you. We only talk about 3 of them here. All right, so if you want to work with the file position, often you need to know what is the file position. That's what ftell does. Right? So ftell, you pass it a pointer to a file. It tells you the current position in the stream. Right? It returns the value as a long value. Right? Why long? Because long has a very large upper limit on most computers. Right? Files can be arbitrarily long in Linux. And so you might have a file that has many bytes. And so the return value here has to be large enough to return that many bytes. At least for the time being, long is probably big enough for most cases. All right, so here's our file. That's the contents of tell.txt, because I use this file over and over and over again for these examples. So that thing looks like it has 5 characters per line and 4 lines. Right? You have to remember at the end of every line there is a new line character. Right? So in fact, every line has 6 characters, right? Including the last one. So there are a total of 24 characters in this file. All right, so the following program is simply going to read and print the contents of the file 1 character at a time. Each time it reads a character, it's going to print out the position, the file position. Right? So basically we're going to use fgetc and ftell. Again, everything's always the same when you read from a file, right? Open the file, close the file. Right? When you open the file, test whether or not it opens successfully. Right? If it opens successfully, go ahead and do something with the file. So here, we're just going to read the file 1 character at a time. That's the loop you write if you want to read the file 1 character at a time. Right? Every time before I read a character, I'm going to first ask what is the current file position. Right? So before the loop, I get the current file position. Each time through the loop, I update the current file position. Right? Every iteration of the loop, I simply print out the position. Print out. Yes, I'm printing out the position. Oh, this is better. I print out the position followed by, the character here. The character followed by the position here. Right? If we see a new line character, I print out the new line character. But I don't print out the new line character. I print out \n. Right? Now remember, the backslash is significant, right? It indicates that you are trying to escape the previous character, the next character. So if you want to print out \n, you have to print out \n. Right? Backslash means you want the character equal to backslash. Right? Then followed by an n. Run the program, and you get the results you probably could guess at. Right? So the A is at position 0, the B is at position 1, the E is at position 4, and then notice the new line character is sitting at position 5. Right? And so on and so on and so forth. So in fact, there really are 24 characters in this file. Right? So if you want to get the current file position in a file, use ftell. All right, so sometimes, well not sometimes, often it's very useful to read a file or read part of a file and then go back to the beginning of the file. Right? So one reason you might want to do this is if you want to get the number of lines in the file before you actually try to read in the rest of the file, before you actually try to read in the contents of the file. Right. So imagine you want to read in the contents of a file and you want to store every line in a separate, in an array somewhere. Right. What do you need to know? You need to know how big is this array, how big does this array need to be in order to store every line in the file. Right. So suppose it's a file, it's just got a bunch of numbers in it, right? An integer in every line. Right. You need to know how many integers are in the file. Right. One way to do this is to scan the file, counting the number of lines in the file. Right. Once you've counted the number of lines in the file, you can go back, right, allocate your array that can hold that many lines of numbers, and then read in the contents of the file. Right? So if you're in that sort of situation, you can use rewind. Right? Rewind puts you back to the beginning of the file. Right? Print the contents of the file max times. Okay, so we're going to use rewind to repeatedly read a file and print the contents of the file. So this program, well, this is 2. So this program is going to read the file twice, right? And it's going to output the contents of the file 2 times. It's just the same program as before, right? So we're just going to read it in one character at a time. We're going to print out the contents the exact same way, right? Except now, right, when we detect that we've read in the last character in the file, right? So in other words, when we detect we're at position 23, right? We're rewinding the file and we call rewind, right? That goes around back, so that sets the current file position back to the beginning of the file, and we're now in the position where we can continue reading from the file, right? So this reads as, this program runs as long as fgetC returns a valid character, right? And as long as the count is less than max, where count is the number of times where max is the number of times we want to print the file. Run that, and not surprisingly, you get A, B, C through T twice, right? So there's where we rewind, and we get the file again. We rewind once more at the end, and then we're done. Right? So use rewind if you want to go back to the beginning of the file. All right, now suppose you don't want to go back to the beginning of the file, you want to go somewhere else in the file. Can you do that? The answer is, of course, you can. Right? You can use fseek. So fseek moves to a specified position in the file, but it's a bit funny in how it does this. Right? Okay, so that's the file that you want to move the current file position in. Right? Offset is the number of file positions to move. Right? But you can move forwards or backwards, or you can move relative to another position in the file. Right? And so the third argument here is called origin, right? Offset is the number of positions to move relative to the origin, right? Notice that offset here is signed, right? So you can move, if you pass in a negative value, you can move backwards in the file, or you can move backwards relative to origin. Okay, so origin can only have 3 possible values. So seek cur is the current file position, right? So if you pass in seek cur for origin and pass in 1 for offset, that goes to the next character. If you pass in -1, that goes to the previous character, right? If you pass in 10, that goes 10 characters into the, forwards in the file. Seek set tells fseek to move relative to the beginning of the file. So if origin is seek set and offset is 0, that's the same thing as doing rewind. Seek end, you're not supposed to use because it doesn't always work. Seek end is the end of the file. Where is it? Somewhere in here it tells you something about seek end, right? I think. Seek end is funny. So I'm going to avoid talking about seek end. But seek set and seek cur, they do what you want. They do what you think they ought to do. Okay, we have to run the next line from the command line because we need to pass in some command line arguments, I believe. Yes, we have to pass in some, yeah, we have to pass in some command line. We have to enter some text from the terminal. All right, so this program is going to print the character in the file at the position specified by the user. So this program is going to run in a loop. It's going to ask you, give me a position to move to, and then it's going to move to that position in the file. Okay, so we open up the file. Notice the comment. Should test the file if fopen fails. I didn't bother testing for it here. Right. So we're going to open up this file. We're going to assume that it works. We're going to go into an infinite loop. Right. I've got a little string here that I can read into. Right. I'm reading one character at a time, so this is okay. I need to be able to store the character plus the null terminator. Buffer. Sorry, I'm being a dummy. This is the, we're reading from standard input here. And so here we're going to ask the user, please pass in a position to seek to. Right now, in this particular file, we know that the position should be between 0 and 23, which is why I chose a buffer of length 3. Right? I can store the 2 and the 3 and then the null terminator. And that's enough. Right? So I can store up to 99 in this buffer. Right? I'm going to use fgets to read the value that the user is writing, is entering in the keyboard. So we haven't done this yet, right? We haven't read input from the keyboard, but the keyboard is normally hooked up to standard in, and standard in is just a pointer to a file in C, right? So you can use fgets with standard in, and that will read from standard input, or your keyboard in most cases. Right? Read up to 3 characters at most, sorry, up to 3 minus 1, so read up to 2 characters from standard input, right? Storing the result in the buffer. Now, what happens if someone types in more than 3 characters? So someone types in the number 1 million, right? I would like to discard the rest of standard in case the user typed in a long string, right? So I'm going to test. Does the buffer contain the character, the new line character? That's what strchr does, right? strchr tests whether or not a character exists in a string. Right? So if it does not, so if the new line character isn't in that string, I know that the user typed in a bunch of stuff on standard input, right? I would like to get rid of the rest of the stuff, right? How do I get rid of the rest of the stuff? So I call this function called discard. What does discard do? It continues reading. So it continues reading from standard input. So getChar also reads from standard input. Right? So this continues reading from standard input until it sees the new line character. Right? So it discards everything until it sees the new line character. So in other words, this consumes all the characters, all the remaining characters that the user typed in, right? So that when they type in the next number, it reads in the next line. Right? So that's what that is doing there. Right? Then it simply takes the value that the user typed in, tries to convert it to an integer. Right? And now we use fseek, seeking from the beginning of the file. Right? That many positions. Right? Do some validation to make sure that the position is actually valid. Right? So I know that the position has to be between 0 and 24, 0 and 23, sorry. Right? So only if the value that was typed in by the user is between 0 and 23 do we actually move to that position in the file. Once we get there, read the character, output the character. This is seek. All right, so does this actually work? Control, okay. Dot, is it here? GCC minus O, seek. Okay, seek. All right, we'll seek to position 0, so that should print out the A, and it does, right? 1 should be the B, right? 23 should be the new line character, which is good, right? So it printed out the new line character here, right? Type in some very long number, right? And it actually reads in, it only uses the first 2 numbers of the string for the position. So it goes to position 10. Notice that it also now waits for the next number to be read in. So 9, right? And it treats 9 correctly. If you didn't discard all of this stuff, right, the next time you read from standard input, all of that stuff is still there, right? So remember, standard input is buffered. So all of that stuff is still sitting on standard input. It hasn't been consumed yet, right? So the next time you try to read from standard input, it starts reading from the 0, right? And so it'll read in the 2 zeros and will think you want to go to position 0. You read again, it'll read in 2 more zeros and will think you go to position 0, right? So that's why you have to discard all of this junk. from the rest of standard input. If input-output seems tricky to you, it's because it is. It's not easy to get right. Nuke this program. All right. So I guess we're out of time. We're actually over time. And so we will finish this discussion next day. And it looks like we need some new material because that's the end of that notebook. So I'm going to have to conjure up some other lectures to talk about stuff. So we'll see what